Hello everybody, I thought I would make a little video here showing you basically some of these review problems and how you would work them out so you can kind of walk through the review with me if you had any questions. So I'm going to try to go through this in a quick and efficient way, but yet explaining what's happening each time. So if you need to fast forward past a section, if you've checked your work and you know what the answers are supposed to be and you need to fast forward past a section to get the part that you want, go right ahead. It won't hurt my feelings any. So you can go ahead and do what you need to do, but basically here's how we can work through these problems, okay? So this is a review worksheet. Your test is going to be similar to this. We need to start here by finding the exact values of the 6 trig functions of theta. So you notice the theta here in the diagram. We need to find this missing side right here because we're going to need that. That is a side length. In order for us to set up all of our ratios, we need to be able to calculate that. So how would a person calculate this side length? We'd do the Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared, or a squared plus b squared equals c squared. So this is 25, x squared, 11 squared is 121. When we subtract the 25 away, we end up with x squared equals, let's see, 121 minus 25 is 96. Yep. And then when we square root that 96, you want to leave your answer in simplified square root form, okay? So we're going to basically simplify this radical by saying 96 is the same thing as 16 times 6, I believe. Let me double check. Yep, 16 times 6. So the simplified answer here, guys, is 4, because that's the square root of 16, square root of 6. Now, once I know that missing side, I can then set up all of my ratios. So the sine would be opposite over hypotenuse, 5 over 11. The cosine, however, is adjacent over hypotenuse, so that would be 4 square roots of 6 over 11. And the tangent is opposite over adjacent. Opposite over adjacent. Now, when you set this one up, opposite is, let me look, oops, wrong one, is the 5. Eraser's not working, there we go. 5 over 4 square roots of 6. But you can't leave a square root down there in the bottom, ladies and gentlemen, so let's remember to rationalize that denominator, get rid of that, and you end up with 5 square roots of 6 over, now remember these two guys right here make a square root of 36, which is 6. So the bottom is 4 times a 6, 24. So that's how we would rationalize that denominator there for the tangent. Now cosecant is, again, flipped over version of sine, 11 over 5. Secant, it would be 11 over 4 square roots of 6. But one more time, you can't leave the square root in the bottom. We'll rationalize that denominator. So we get 11 square roots of 6 over, remember these two guys multiply to make square root of 36, which is 6. So 4 times 6, again, 24. And then the cotangent is the flipped over version of the tangent. So that would have been 4 square roots of 6 over 5. So finding that missing side, setting up those values. Now number 2 is very similar. Number 2 is very similar in that we have a sine value here. We just need a good picture to get us going. So on this one, I would draw a good picture here. Place your theta in wherever you want. It doesn't matter. It can be on the top or bottom. The acute angle, okay? The 90 degrees needs to be in there. And remember that the sine is opposite over hypotenuse. So opposite, that theta is 8. Hypotenuse is 15. And again, we're going to do that Pythagorean theorem to find that missing side. So 8 squared plus x squared equals 15 squared. And I'll just tell you that for the x, I got the square root of 161, which could not be broken apart. So I'm going to leave that alone right there and use that as we set up all of these values. So the cosine is adjacent over hypotenuse, or the square root of 161 over 15. And tangent is opposite over adjacent, so 8 over the square root of 161, but we can't leave that 161 down there like that. Here we go. We'll rationalize the denominator. We get 8 square roots of 161 over 161. Yep, that's icky, but we'll leave it. Cosecant, flipped over version of sine, 15 over 8. Secant, 15 over square root 161. Again, rationalize that denominator. So 15 square roots of 161 over 161. And then cotangent would be square root of 161 over 8. All right, now number 3 says we need to solve the triangle. Number 3 is asking you to find every single piece that's missing. So what we know already is angle B is 35. And side C, with the little c, is 10. And we need to find everything else. Well, the first thing I should find is that missing angle up there. Angle A has to be 55 degrees, and that's because there are 180 degrees in a triangle. After that, we can go ahead and set up a sine, cosine, or tangent here to solve for, let's say, A or B. So if I was going to solve for A, I'm standing at the 35. I have the hypotenuse of the triangle, so I might set up cosine because A is adjacent. So we'd say cosine of 35 equals adjacent over hypotenuse. And when you solve, type in your calculator there, we should get A equals 8.19. And then the same sort of thing happens with B, but B is opposite my 35, so I might set up the fact that sine of 35 equals opposite over hypotenuse. And then for that B value, I got 5.74. So using those sine cosine ratios to help find missing sides, that's another big part of what we need to do. Number 4 is a sine cosine tangent problem again, but without a picture, so you need to draw one. John, there's John. Little guy right there. He's standing 150 meters from a water tower. It's a pretty bad drawing, I know. And he sights the top of a water tower at an angle of elevation of 36 degrees. So he's looking up at 36 degrees. How tall is the water tower? So basically this is another trig problem here. We're trying to find opposite. We have adjacent, so we'll set up tangent. Tangent 36 equals x over 150. And if you go ahead and do those calculations, you should get 108.98, and that would be meters. Okay. Now the next part of this involves us understanding our special right triangles. So you notice here I say no trig. This is you remembering those relationships. So the first thing we see here is a 45, 45, 90 on number 5. That means that the legs are equal and the hypotenuse is the leg times the square root of 2. So I notice one of my legs is 13. That means the other leg will be 13. And that means this hypotenuse will be the leg times the square root of 2. Well, the leg's 13, so this is 13 square roots of 2. Now, if we look at number 6, this is a 30, 60, 90. We have this measurement right here. That's across from the 60 degrees. That's the long leg. Now, remember with all of our work here, we've been working on these special right triangles. The long leg is the short leg times the square root of 3. So if I know this, then I know the short leg had to be just 3. Because if you take it times the square root of 3, that's what you would get for that long leg. And if the short leg is 3 and the hypotenuse is twice as much, then that means the hypotenuse is 6. So number 7, another 30, 60, 90. This time we have the hypotenuse. The hypotenuse is twice the short leg, so 2 times the short leg. So if I know that's an 8, that means the short leg must have been 4, because 2 times 4 would have made 8. And if that's a 4, then my long leg is 4 square roots of 3. Remember those formulas. Remember how we were working with those on a graph. This is just going back to when they weren't on a graph. So now we're on the drawing angles portion of this. And to draw an angle with this given measurement, hopefully this isn't too difficult for you. We've been doing lots of practice here. So we're going to start our initial side, and then we're going to go ahead and draw that angle. 180 degrees would be here, so 185 is a little bit further. That's an angle with 185 degrees. Now negative 420, negative direction means you go down first. So I'm going to go ahead and place, my starting initial ray there, and then we're going to go down around 1 time, and then that's 360. And then a little bit more. So this would be negative 420 degrees, okay? Seeing that motion going around more than once, we need to see that. From there to there is negative 420. So we're at the portion now where we have coterminal angles. Remember, coterminal means they end in the same spot. So if I have a 45-degree angle and I want it to end in the same spot, I would go around one more time, or 360 degrees to make that happen. And that leaves me with a 405-degree angle. But I don't have to go around in a positive direction. I can also go around on the negative direction. So 45 minus 360 is negative 315 degrees. Notice that one angle is negative and one angle is positive. That's what we want. That's what we needed to do. Now number 11 is converting into radians. So the formula for converting into radians is degrees over 360 equals radians over 2 pi. So if I set this up, I'm going to put 130 because that's the degrees over 360 equals x, I don't know the radians, over 2 pi. And now when you cross multiply, 360 times x is 360x. And then 130 times 2 pi would give you 260 pi. And now we would have to divide by 360. Divide by 360. So 260 divided by 360, you want to simplify that fraction. 260 divided by 360, remember there's a pi there, simplify that fraction. Ask your calculator or start dividing out 10, maybe 12, maybe 14. So see if you can divide that out and you get 13/18 pi. Okay, so that would be the simplified version for the radian answer. The radian answer will look like that in a fraction with a pi. So number 12, let's do the reverse. This time we have a pi value or radians and we need to convert it into degrees. So the same formula, except this time I don't know the degrees, so I'm going to put an x there and I'm going to place 360 there because that's degrees over 360 equals radians negative 3 pi over 4. Yep, that whole fraction goes on the numerator of that fraction, okay, over 2 pi. So remember pi's over pi's, we talked about simplifying that first, and then you get 2 times x if you cross multiply this way. 360 times negative 3/4. 360 times negative 3/4 is negative 270. Divide by 2, divide by 2. X is now alone, it's negative 135 degrees. Okay, 13, convert the terminal side of an angle, or the terminal side of an angle in a standard position contains the point negative 4, 3. Find the exact values of the trig functions. Okay, so let's draw a good picture, guys. We need to go negative 4, so that's over to the left, so negative 4 this way, and then positive 3 up. So there's my triangle, except it's at the origin. I just wanted you to be able to see it, okay? Negative 4, 3. We need to find this hypotenuse side right there. Again, Pythagorean theorem is our friend when we need to do that. So 3 squared plus negative 4 squared equals x squared. 9, 16, x squared. When you solve for x here, you should get x to be 5. Okay, so the hypotenuse is 5. So now remember where our theta is in these instances, guys. That reference angle is always at the origin there. So now we can stand there and set up the sign. The sign is opposite over hypotenuse, so 3 over 5. Cosine is adjacent over hypotenuse, so negative 4 over 5. And tangent is opposite, 3 over adjacent, negative 4. There we go. And remember, these are just the reciprocals. Okay, so we'll go ahead and fill those in. There we go, all done. So number 14, we're on to number 14 now. Almost to the end. Number 14 is sketch the angle, then find its reference angle. So 135 degrees, we'll start there, and we'll go 90, a little bit more. So if this is 135 degrees, the reference angle comes from this terminal side right here. This triangle we draw right there, we want to know how many degrees are right there in that corner of that triangle at the origin. So think about, we went 135 degrees. How much further would we have had to go to get right to that 180 mark? We would have had to go 45 more degrees. So the reference angle is 45. Okay, we're going to use that skill now as we complete these last 6. The last 6 here involve drawing that picture and finding those reference angles. So the sine of 150. So if I was going to draw 150, a little bit more to right here, and then I would have this triangle. In the corner of this triangle would be 30 degrees because I'd have to go 30 degrees more to get to 180. Now this means that this is a 30, 60, 90, and we don't have any coordinates here to put numbers on, so we have to rely on our special triangles. We talked about making the short leg equal to 1. The short leg is across from the 30 degrees, so it's going to go there. The long leg will be the square root of 3. In this case, it's actually going to be a negative square root of 3 because we're over on the negative side of the x-axis. And the hypotenuse will be labeled with a 2. So when you set up the sine fraction, remember that you're standing at that 30 degrees or right there at that origin reference angle. And now we set up opposite over hypotenuse. It's 1/2. That's what the sine of 150 degrees is. Now, number 16 is the cosine of 270. So we'll try to draw 270 degrees here. 270 goes around like this, stops right here. There we go. Now, can I draw a triangle from where I ended? No, I can't draw a triangle straight up to the x-axis. I can't go horizontal or diagonal. I have to go straight up and down. I can't draw a triangle there. When that happens, we use our unit circle, and we use that coordinate, 0, -1, because that's down here at 270. And if we read our little green chart, it says the cosine is x divided by the radius. So the x value of that point is 0 divided by the radius of the unit circle is 1. So we have 0 as our answer. Now let's do tangent of pi over 4. The first thing you want to do is figure out what pi over 4 is. That's 45 degrees. Using our unit circle, we can see that that is 45 degrees. Now we will go ahead and draw that picture. We're going to draw a 45-degree angle. There he is. We're going to go ahead and drop that triangle straight down. This would be 45. The legs are the things that we would want to make ones. And the hypotenuse would be the square root of 2, based on our special right triangle information. Now, do we need to adjust any negative signs here? No, this is positive x, positive y, looks good. Now, if you set up your opposite over adjacent, you'd get 1 over 1, which is just 1. So 17 should just be the number 1. 18, tangent, -30. I'm going to go ahead and draw that -30 degrees. Make my triangle. This would be 30 degrees then in that corner. It is a 30, 60, 90. Where's the short leg? Across from the 30. We want to make that short leg be a 1. The long leg will be the square root of 3, and the hypotenuse will be a 2. Now let's adjust based on any signs we might need to change. Looks like the x-axis is positive, so the square root of 3 is still positive. This needs to be a -1. Hypotenuse is good. And now when we set up the tangent, we want to set up opposite over adjacent. That's 1, or sorry, -1 over the square root of 3. Can't leave the square root of 3 in the denominator here. So we'll go ahead and rationalize the denominator. We get negative square root of 3 over 3. Now 19 is the cotangent of -pi. So let's go ahead and find out where -pi is first. Negative pi is the same thing as saying 180 degrees negative. Okay, so -180. So if we draw that angle, we're going to start on here. We're going to go -180 over to here. Can you draw a triangle from where we stopped to the x-axis? No, because it's on the x-axis. So again, we need to use that unit circle. Use those coordinates that are on there. Use our reference to, in this case, it's tangent we're going to need to look at because cotangent is the inverse of tangent, so reciprocal of tangent. So if we have tangent is y over x, then my cotangent would be x over y. So x over y, I will place 0, or sorry, my bad, -1. Let's see if I can get that erased. Okay, -1 over 0. Can't have a 0 in the denominator, so this one is, I'm running out of room, undefined. And then last but not least, number 20. First of all, -3 pi over 4, how many degrees is that? This means -135 degrees. So we need to draw -135, which would place us, right about there. This is my starting spot, got a little sloppy there. And my triangle would go right there. So how much further would I have had to go to get to that 180? If I was at 135 to get to 180, I'd have to go 45 more degrees. So this is a 45, 45, 90, which means I'm going to make the legs be 1 and the hypotenuse be a square root of 2. And then I need to adjust. Actually, I need to adjust both because this is over negative at 1 on the x-axis, down 1 here on the y. And now when we go ahead and set up our sign, it's opposite over hypotenuse, which would be -1 over the square root of 2. But we can't leave that square root in the bottom. So we're going to go ahead and place him, rationalize, okay, place him up there. And I'm going to see if I can find a spot to write my answer here. That would give me negative square root of 2 over 2 for my final answer. Okay, I hope working these all out for you is beneficial for you. If you took time to watch this, I want to thank you for being proactive and for taking the time to make sure you know what's going on. So I will see you later.